Okay, hopefully much of this content will be kind of a review of your imaging class from last semester, but that should just do nothing but help and build upon previous knowledge, which is always the best thing. Alright, so we are going to first talk about some external components of the X-ray tube. So X-rays are produced isotropically, and that's just kind of a fancy word for saying that they're produced actually in all directions. So we see here there's like a central point of X-ray production, and then they actually kind of go off in all directions. It's kind of easy to forget that this happens because the only thing we want or use are the ones that come out in this direction, the useful beam they call it here, and in the direction of the patient to make the image. So because they are produced isotropically, we have something called protective housing. And this is actually what we kind of work with in the X-ray room. Same thing with a portable unit. It's what has those handles on it, so we can actually move it around according to our environment and the patient, things like that. It helps guard us against leakage radiation as well. Protects us against the risk of electric shock, of course, because it's usually filled with a lot of oil. It provides for mechanical support. Again, that's what we use to move the tube around. And then it helps dissipate heat through that oil I mentioned just now, and then sometimes cooling fans as well are there. Within that protective housing is actually Pyrex glass or metal for the anode and cathode made elements. So if we go back to this picture here, we can see we have the protective housing with our little window here. But then here, this dark black line here is kind of letting us know that's where the glass or metal enclosure itself is. Now, inside that enclosure, there must be a vacuum, which basically means there's nothing in that space. So no air, no oxygen atoms, nitrogen atoms, nothing that we might find in regular air. Nothing. Because, believe it or not, those atoms found in normal air could interact with the electrons from our cathode, and instead of getting X-rays, we'll get all these interactions between those cathode electrons and oxygen atoms, or those other atoms found in air. So it needs to be completely empty. Another thing is glass enclosures used to be more common, but the thing is over time tungsten kind of vaporizes, is what we call it, and basically it gets stuck to the glass. And then with that we get interactions that we don't want, just like as if air were there, and then our X-ray production is greatly decreased, or it's less efficient. Metal enclosures are much more common, and they last a lot longer. Let's go further into cathode filaments. So the cathode is the negative part of the tube, and its main components are going to be these filaments and the focusing cup. Those are the two main parts that we're going to talk about. So these filaments emit electrons when they're superheated, and this is known as thermionic emission. So if we broke down this word, we'd see therm, kind of like thermal, or heat. So they're emitting electrons because of an immense amount of heat. These filaments are usually made of thoriated tungsten, and all that means is it's mostly tungsten with some thorium added in there as well. And tungsten is used a lot in our X-ray tube, right? Because it can handle a very high heat and does not produce gas as easily, which can then start to interfere with the X-ray process. Again, we want to keep atoms, including tungsten atoms, in an exact spot so that we don't get other interactions we don't like or interactions in another place in the tube that we don't want. So usually there are two filaments, a large one and a small one, hence large and small focal spots, and they're encased in this focusing cup. Now we can see how important the focusing cup is in this picture on the right here. So if we did not have that focusing cup, what we'd end up having are all these electrons that, when they're finally pushed toward that anode, could just start to kind of fly everywhere. But when we add a focusing cup, we can actually focus those electrons heading toward the anode. Further on that focusing cup, it's also negatively charged, and it actually receives a charge as part of the secondary circuit. So there's actually a little tiny connection between what supplies the anode. That little part of the circuit actually also helps supply a negative charge to the focusing cup. Now what that negative charge does is it repels the negative charge of those electrons that we saw here just now. So we have a negative here in the focusing cup and negative charge of the electrons. And we know now that a negative charge and a negative charge are always going to want to repel each other. So what the focusing cup does is it repels all those electrons into kind of a ball there. And those grouped electrons we call a space charge. That space charge will reach a certain size before it becomes difficult for any more to be boiled off. And this effect is called the space charge effect.